Trigonometry deals with triangles and it deals with angles. First thing that we learned was what is an angle in standard position. And so we always measure an angle starting from the positive x-axis. And you can measure the angle, most of the time you measure it in the counterclockwise direction. So if I had an angle here in quadrant 3, it would go 90, 180, and then whatever it is, if I was estimating this, that might be an extra 40 degrees. That would be an angle in standard position. We can measure angles also backwards, and we would just call them negative, but for the most part in grade 11, we looked at starting here at 0 degrees, then 90 degrees, then 180 degrees, then 270 degrees, and when you get back to where you started, that's one full circle, that's 360 degrees. And we call this quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Now, every angle in standard position has a reference angle. So that was the second main definition that we looked at. And a reference angle is always to the nearest x-axis. So you're either looking at this green one or this purple one, but never to a y-axis. So in this case, the angle to the nearest x-axis would be back to this purple one. It would be right there. And to figure this out, we would figure this angle to be 40 degrees. My screen is off. Because you could do 220 degrees minus 180. So we really, for reference angles, we really use your x-axis to figure them out. Does it make sense if your reference angle was in quadrant 2? That your actual angle would be 180 minus your reference angle. In quadrant 3, it's 180 plus your reference angle. And if you had a reference angle in quadrant 4, well, all the way around would be 360, and then you would subtract your reference angle. So your reference angle helps you find your angle in standard position. Your angle in standard position can help find your reference angle. And then we connected the reference angles and angles in standard position to trigonometry, and we introduced the cast rule. Now your cast rule tells you where trig functions are positive, and opposite-wise, you can use it to figure out where things are negative. So if I had cos of theta is positive 1/3, I would know that this would be in quadrant 1 or quadrant 3, because the A stands for the place where all of them are positive, and the C says that only cosine is positive. So if I told you something like tan is negative, less than 0, and sine of theta is bigger than 0, you would have to figure out, based on those two things, it can only be in one quadrant. Sine of theta bigger than 0 means 1 and 2. These are our possibilities. But tan less than 0 means that it has to be in 2 and 4. And so the only one that has both of those would be quadrant 2. Sometimes it's easier if you x things out. So sine being positive means you would x those two out. And tan being negative means you would x those two out. And then the only one that would be left would be quadrant 2. Now we use our cast rule to help us solve questions. And that worksheet that most of you finished and I handed back today had questions like solve for theta, 0 less than or equal to theta less than or equal to 360. This part here tells us that we're looking in all 4 quadrants. And if I had a question like 3 tan theta plus 4 equals 0, I could solve this. I could solve this by first getting tan by itself. I can subtract 4 on both sides and then divide by 3. I'll do that all in one step. And I get tan of theta equals negative 4 over 3. What does this mean? Well, SOHCAHTOA, tan is part of a triangle, but since tan is negative, our cast rule tells us that it's not in quadrant 1 and not in quadrant 3, because that's where tan is positive. So it must be in quadrant 2 and quadrant 4. And we can draw then an angle in quadrant 2, and we can draw an angle in quadrant 4. And with each of these angles, you can draw a right-angled triangle back to the nearest x-axis so that you have a reference angle. Now, tan of a reference angle will give you the same answer as tan of the regular angle, but the reference angle will always be positive because it's dealing with an actual triangle. And that's grade 10 trigonometry. Grade 10 trigonometry, you dealt with only triangles, everything was positive. You didn't have to worry about anything past 90 degrees. Now, we know that tan is opposite over adjacent, so in this triangle, you would know this side is 4, this side is 3, same thing here. Opposite is 4, adjacent is 3. And in that triangle, you definitely can find your reference angle using grade 10 trigonometry. Tan of your reference angle is positive 4 over 3. So I chose this example on purpose because when you're finding your reference angle, you always have the ratio positive. So if I'm finding my reference angle, that 4/3, I ignore the negative, it's going to be positive 4/3, and then I can go to my calculator and I can go tan inverse of 4 divided by 3, and I get 53.1 degrees. And if I know that the reference angle is 53.1 degrees, I now look at my pictures and I can see, oh, this one's going to be 180 minus 53.1. If I did that, I'm going to get 126.9 degrees. And this one's going to be 360 minus 53.1. If I do that, I'm going to get 306.9 degrees. It's been 2 weeks. I was a little nervous, the mental math. I'd be like, but I still can add and subtract. So far, so good today. It's a good start to the new year. Can you imagine? Just like randomly, oh, would it be crazy if every new year randomly you got one new skill that you were amazing at that you were not amazing at the year before, but you also lost a skill? It'd be like a lottery. Okay, sorry. That'd be devastating if I, lost my math skills, but all of a sudden was like a poet. Like, oh, this is going to be a rough new year. Okay, so that's solving. We had solving equations on that worksheet that looked like this. We had solving equations on our worksheet that were quadratic. So you could have a question that looked like this. 2 sine squared theta plus 3 sine theta plus 1 equals 0. And we could solve, again, when you get a question like this on your test, it'll say solve for theta, and then it will also tell you where to look. Sometimes it might only look between 0 and 180, quadrant 1 and quadrant 2. Most of the time, you will get questions that say, look all the way in all 4 quadrants, because that's what we're trying to get used to, our Castro. So because this is a quadratic equation, we have to think about factoring or quadratic formula. Almost all of the ones that you will get in grade 11 deal with factoring. In grade 12, you get these questions again, and then they say, well, then it can be, since you've learned grade 11, you might have to use a quadratic formula, you might have to factor. In this one, the only way to get 2 sine squared with nice numbers would be 2 sine theta and sine theta. The only way to get the last one of 1 with multiplying with nice numbers would be 1 and 1. And now you have to check, does this actually work? Should these be positive signs or negative signs? To get a positive one, they either both have to be positive or both have to be negative. We want a positive 3. So can you see that if you check your outside and your inside, you multiplied this out and FOILed it out and multiplied everything, that they would both have to be positive, because 2 sine theta plus 1 sine theta gives us 3 sine theta. A common error is when students factor, they decide not to write the equals 0. Okay, I didn't deduct on your worksheet. I added the equals 0 on your worksheet if you forgot it. I marked 5 questions in depth on your worksheet. But you can check to see, did you always remember the equals 0? Then, once you have factored it, the reason we factor is we change adding to multiplying, and when you have 2 things that multiply to equal 0, either the first one is 0 or the second one is 0. If the first one is 0, if this is equal to 0, and you don't have to show that first step, most people just can rearrange things and figure this out right away to be sine of theta equals negative 1/2. And here, sine of theta is equal to negative 1. So according to the cast rule, here sine is negative. It's not in quadrants 1 and 2. It would be in quadrants 3 and 4. Same thing here. Sine is negative. You would think quadrants 3 and 4. Now this question I did in particular because this one uses your special triangles. So another thing for review is you had 2 special triangles that you needed to know. One of them was a special triangle with 45 degrees, and one of them was a special triangle with 30 degrees and 60 degrees. And in the 45-degree triangle, both of these sides were 1, and this was root 2. And in the 30-60 degree triangle, the bottom was half of the hypotenuse. And so the reason this is important is because now we've got sine is 1/2. We can use the triangle to figure out which angle that is. So 1/2 would show up as this side here divided by the hypotenuse. For sine, sine is opposite over hypotenuse. Can you see that the angle that that uses to be opposite over hypotenuse would be the 30 degrees? So without a calculator, you could determine that your reference angle is 30 degrees. So this would show up on a non-calculator question on a test, that you would find out that your reference angle is 30 degrees. And then, because it's in quadrants 3 and 4, 180 plus 30 degrees is 210 degrees. In quadrant 4, you would go 360 minus 30 degrees, 330 degrees. And if you wanted to, you could draw those, label 30 degrees, and then think about finding those angles that way as well. The other thing that this question reviews is the graph of sine theta goes up to 1 and down to minus 1, 90, 180, 270, and 360. And you need to use the graph whenever sine is equal to 0 or 1. Because technically, you cannot draw a triangle when sine of theta is equal to 1, because as a fraction, that would be 1 over 1. And that would mean your opposite side is 1 and your hypotenuse is 1. They're exact. That would just give you a straight line. Question?
Do you have to memorize that on the bottom, like what?
Yes.
Okay.
Yes. You have to know the graph of sine, and you have to know the graph of cosine. So, -1 only happens once, and from the graph, we can figure out this angle to be 270 degrees. So this one you could do just with special triangles, no calculator necessary. Interestingly, is if you did have a calculator and you solved this, okay? What would you do if you were doing this side with the calculator? Well, you would go to your cast rule, and you would say it needs to be, since sine is negative, in quadrants 3 and quadrants 4. And then you would have probably drawn a picture in quadrant 3 and quadrant 4, and then found your reference angle. You would find your reference angle by using the positive value, so it would be +1, going to your calculator, doing sine inverse of +1 on your calculator, and your reference angle would come up on your calculator as 90 degrees. So now you imagine a reference angle here of 90 degrees and here of 90 degrees. Obviously, I have not drawn this to scale. But in quadrant 3, you would find the actual angle by doing 180 plus 90. Can you see that you would get 270? In quadrant 4, you would do 360 minus 90. You would get 270 again. So even our methods from before would still work. You would just have this weird feeling in between because you would get a reference angle of 90 and that seems like something went wrong. And technically, something is going wrong because you can't actually draw a triangle with sine theta equals 1. That's why we use the graph. But the mathematics still works out with a reference angle of 90 degrees. Okay, there's a solving question. Next up, we sometimes, well, maybe I'll just start a new page here. There we go. Sometimes they give you a point. Okay? Let's say I give you the point -3, 2. just give you the -3 part. And the 2 will show up later. Did anybody forget that the computer did this? Okay. You could draw that. Obviously, it's going to be, well, not obvious because you can't see the 2. There it is. Just wait for the bracket. That's going to be in quadrant 2 because you would go 3 to the left and 2 up. And if you drew your 4 quadrants, which apparently I can do now, that point would be there, and I could draw an angle in standard position. So if I give you a point, I might ask you, could you find tan of theta? Well, I could draw the triangle to the nearest x-axis, label my reference angle. I would know that this length is 3 and this length is 2. And so if it asked me to find tan of theta, I would know that tan is opposite over adjacent, which would be 2 over 3, but because it's in quadrant 2, tan would have to be negative. If it asked me to find sine of theta, quadrant 2 is going to be positive. Sine of theta would be opposite over hypotenuse, so it's going to be 2 over, but I don't know my hypotenuse yet. However, you can do a squared plus b squared equals c squared. 4 plus 9, this side would be the square root of 13 if you did a squared plus b squared equals c squared. So sine of theta would be 2 over the square root of 13. And this is where we review our radicals. In our radicals unit, you're not allowed to have a square root on the bottom, so we would have to multiply to rationalize the denominator. We would also have to simplify the square root if it could be simplified, right? But square root of 13 doesn't simplify. Quick review of simplifying here. If I gave you the square root of 45, square root of 45 is a perfect square of 9 times 5, right? So we're always looking for this perfect square because square root of 9 is 3. So if you can simplify a square root, you have to simplify a square root, and there's a little review of that. I could also give you this point question. So the point question, you could find tan theta, you could find sine theta, you could find any ratio, but you could also be asked to find theta. If you were asked to find theta, first you would decide on one of your trig ratios, right? In this case, I would probably solve my reference angle by using tan of my reference angle opposite over hypotenuse. Again, we use our reference angle, and when we use our reference angle, even though tan is negative in quadrant 2, we use the positive value. So now I've got tan inverse of 2 divided by 3. That gives me 33.7 degrees. And because it's in quadrant 2, I would subtract that from 180 and get 146.3 degrees. So I could give you the point and ask you to find certain things. I could also give you the angle and the length of the line segment and ask you to find the point. So let's look at what that would look like. Let's say the angle is 220 degrees, and the line segment's length is 4. So I can draw this picture. Here's my 4 quadrants. 220 will end up in quadrant 4. I know that this length is 4. And this angle here is 220 degrees. Well, I can draw this back to the nearest x-axis and make a triangle, the right angle. I would know that in this triangle, my reference angle is 40 degrees. And if I want to find this point, I need its x-coordinate and its y-coordinate. Can you see that its x-coordinate is whatever that length is? Its y-coordinate is whatever that length is. And the y-coordinate would need to be negative, and the x-coordinate would need to be negative because it's in quadrant 3. So drawing the picture is the hard part here. Knowing what is being told to us, we know that we have a length of 4, I've got 220 degrees, I can make a triangle with a reference angle. And once I have that triangle with that reference angle, can you see that you could find x using cos? Cos of 40 degrees would be x adjacent over hypotenuse. And I could get x by itself by multiplying both sides by 4. And so if I do 4 cos of 40, I get 3.1. So I now know that my x-coordinate would have to be negative 3.1 because it's going to the left. And if I wanted to find y, well, that would just be sine and since it's going down, my y-coordinate would be negative 2.6. So part 1 of our unit was the casserole reference angles in standard position. They still used right-angled triangles and SOHCAHTOA from what you learned in grade 10. Then our second part of our unit said, what happens if we have triangles that don't have right angles? Then you're not allowed to use a squared plus b squared equals c squared, and you're not allowed to use SOHCAHTOA. So we learned 2 new laws to deal with those. And the first law that we learned was the sine law. And the sine law, so you have a triangle that doesn't have a 90-degree angle, and you need to solve a triangle that doesn't have a 90-degree angle. You need 3 pieces of information, and in those 3 pieces of information, you need to have at least one side. So if I knew this side was 8, this side was 4, and this angle was 20 degrees, I could solve this triangle. How do we know that we use the sine law instead of the cosine law? We always look for we need a side and its opposite angle. This situation we have here. We have a side and its opposite angle. If that's the case, then you can always solve for things that are opposite. So for example, I know this 4. The only thing I could solve for on this triangle at this point is that angle x, because it's connected with the 4. Opposite angles and sides always go together. So, that in mind, the sine law either lets you put the side on the top or the sign on the top. Depending on what you're solving for, that's what determines what I would recommend you put on the top of your fraction. In this case, we want to solve for x, so I would put sine of x on the top. That one goes with the 4. On the other side, I put sine on the top with 20 degrees. That one goes with the 8. And if we type that into our calculator, 4 sine of 20 divided by 8, we get 0.171. According to our cast rule, sine is positive. It could be in quadrant 1 or quadrant 4. We would need to find our reference angle. Our reference angle would be sine inverse of the positive value, which it's already positive. So you would find your reference angle to be 9.8 degrees. Which means in quadrant 1, it would be 9.8 degrees. In quadrant 2, it would be 180 minus 9.8, which would be 171.2 degrees.
So 170.2?
170.2, thank you. There, see, mental math is slowly going. Maybe it's over time. By the end of January, I'll be like complete mess. 170.2. Now, in these two, if you imagine them, I hope that you can see that this is impossible. Because if I put 170.2, then it's over 180. Angles in a triangle add up to 180. Okay? You might have also seen that right away, because when you get two answers, do you remember we called that the ambiguous case? And the ambiguous case happens when the angle opposite the angle that you know is less than the adjacent angle. And this time I made it so that the angle was bigger. So we only have the one answer, and x is equal to 9.8. Now sometimes on your test, I might ask you to solve the entire triangle. So now that you've learned that this is 9.8, can you see that you could also solve for this one? And then you could use your sine law again and solve for this one. So you will get questions that ask you to solve for everything, okay? And in a single question, like this has a single triangle, then you would only have to solve one triangle. If you had the ambiguous case, so I'll draw here's an example of the ambiguous case, because it's still the sine law, because you know an angle and the opposite side. But since the angle of the opposite side is shorter than the other side, there's the possibility of this one. And do you remember when we drew this, that you could have also taken this side of 30 and swung it around, sorry, this side of 3, and swung it around and made that angle. And this time, when you solve for sine, I may as well just do it, because what can I solve for first? I can solve for that x. When I solve for that x with sine, look what happens. Sine of x over 4 equals sine of 40 over 3. So I get sine x by itself by multiplying both sides by 4. Type that into my calculator. And I get 0.857. Sine is positive according to the cast rule. It's in quadrant 1 and quadrant 2. I find my reference angle. Here I'll round it to the nearest degree, 59 degrees, so that in quadrant 1 it would be 59 degrees, in quadrant 2 it would be 180 minus 59 degrees, 121 degrees, and if we look, both the 59 and the 121 still are possible, because they don't add up to more than 180. And in these questions with the ambiguous case, they are long. Maybe you want to split your page in half and do the work separately for them. But can you see, if you knew the 54, you could figure that out. And if you knew the 121, you could figure that angle out, because they add up to 180. And then you could find the other side on both of them with the sine law again. So, sine law, we need an angle and its opposite side. The hardest sine law question that I can make is, why is this one a little bit hard? Let's go 50 degrees, 70 degrees, and 10. Initially, are we given a side and its opposite angle? No. However, how do I know this so easily? Because it has to add up to 180. So because I can figure that angle out so easily, can you see that you do know an angle and its opposite side? This would still be a sine law, even though initially your brain might tell you, oh, I don't know an angle and its opposite side. What do the questions look like that aren't the sine law? Well, that's our cosine law. Here's an example of a cosine law question. I know the 7, but I don't know its opposite angle. I know the 6, but I don't know its opposite angle. I have 3 pieces of information and at least one side. So this is the cosine law. The cosine law appears in 2 different ways. It looks like this, and both of these ways are on your formula sheet. Or it looks like this. And what is important is not what the letters are and labeling letters on your triangle. Because I could make this triangle A, B, C, and it wouldn't match up with the A, B's, and C's there. Or I could make this triangle P, Q, R, and then you're like, I don't have P's, Q's, and R's in my formula. How do I do? Well, just like the sine law, the letters on your formula sheet don't matter as much as knowing that angles go with opposite sides. So, we have this angle 50, it will go with this side here. And so in the cosine law, you could actually solve for little p, and this angle goes with that side, this angle goes with this side. The other sides actually do not matter the order. Mathematically, switching A and B around won't matter. So in this first example, we could solve for little p, and since we're solving for a side, we would use the first one. The second formula is more useful when solving for an angle. Solving for a side, okay, so now I just write p squared equals, doesn't matter which one's a and which one's b. And you could type all of what's on the right-hand side. Highly recommended typing it all in at the same time, so exactly like I see it. I typed the whole right-hand side in, and I got p squared equals 31.00, uh-oh, 58, dot, and then to get p, I would have to square root both sides. Normally when you square root both sides, you should add plus or minus. It's not necessary in this question because we're finding a length, so only the positive answer makes sense. We don't have to write plus or minus, but algebraically, you should write the plus or minus if you were solving a non-triangle question. So the answer for P would be 5.57. What do questions look like where you want to use the angle formula? The angle formula questions is when you're solving an angle and you have three sides. So now, let's say I'm solving for this angle up here. This angle is connected to the opposite side of 7. So when I'm writing out the formula that I had up there, the cos C and the little c, those are the ones that go together. A and B don't match the order. So cos of theta, I'm going to have 6 squared plus 8 squared minus, and the 7 squared has to go there. Divided by 2 times 6 times 8. Again, I can type this whole thing into my calculator all at once. If you have a calculator that has a fraction button, use it. If it doesn't have the fraction button, you will have to put this and this into an extra set of brackets. So try it on your calculator right now to see if you get the same answer that I have here. You should get cos theta is 0.53125. Now, according to your casserole, cos is positive. So it's in quadrant 1 and quadrant 4. However, can you see that if you got an answer in quadrant 4, it would be somewhere between 270 degrees and 360 degrees? In a triangle, that doesn't make sense. So I'm going to X it out in a different color just to remind us that that one won't be an answer. All we need to find is the angle in quadrant 1. So if I find my reference angle in quadrant 1, it's going to be the same as my actual angle. And I get 58 degrees. Now, if you were asked to solve everything in this question, you now have the 58 degrees. You could now use your sine law to find the other angle and solve it completely. The last thing that we looked at, or the last thing that I want to do as part of the review that we looked at in this unit is we looked at finding the area of a triangle. Okay? Up until now, you have only had this formula, 1/2 base times height, for the area of a triangle. That formula only works if you know a height. Right? I could do this triangle because I have the 5 as the height. I could do, if I told you the height was 3, I could do that triangle. But we also learned in this unit 2 new area formulas for triangles when you do not know the height. One of those formulas was 1/2 AB sine C. This is when you know 2 sides and an angle that's not connected to those 2 sides. So notice the letters again have this idea that angles go with opposite sides. This would be this situation, because the angle, the 30 degrees, is not connected to a side that we know. If we have this, I would get 1/2 7 times 8 sine of 30 degrees. This could be on a non-calculator part of your test. Why? Because 30 degrees is part of our special triangles. If you look at your special triangle, and one of the things you might like to do right at the beginning of your test, on a scrap piece of paper or on the top of your page, is draw those triangles down. So from here, sine of 30 degrees, opposite over hypotenuse, I would know that it's equal to 1/2. And now a little bit of mental math, right? 7 times 8 is 56. Cut in half once, gets you down to 28. Cut in half again will get you down to 14. This was one area of a triangle formula that was new for us this semester. It's on your formula sheet. The other new formula was the formula for the semi-perimeter. Actually, I'm going to make this, just make numbers nicer. So, there's an area of a triangle formula where you know all 3 sides. In this new formula, the letter S is called the semi-perimeter because it adds the perimeter. A plus B plus C would be the perimeter, which if I add that up, that gives me 20. The semi-perimeter is cutting that in half. Since the perimeter is 20, the semi-perimeter is 10. And this area formula is just 10, and then 10 minus side 1, 10 minus side 2, 10 minus side 3. Plug this into, well, if this was a non-calculator question, you would have 10 times 5 times 3 times 2. 3 times 2 is 6. 6 times 5 is 30. 30 times 10 is 300. If this was calculator, you could just type it in your calculator, push enter. If this was non-calculator, you would leave your answer as a square root, but it would have to be simplified. How do we simplify square root of 300? We have to see if there is a perfect square that divides it. I hope that you can easily see that this is 100 times 3. And since you know the square root of 100, our final answer would be 10 root 3 without a calculator. I'm pretty sure the one I put on your test, I put it on the calculator part. So then you could just do square root and type it into your calculator and figure it out. Wow. That is the whole unit in one class. Question?
Can you scroll up a bit?
I can scroll on a bit for sure.
That's it.
That's good.